Hi everyone. Let's say you have a service to run, either it's probably backend or frontend, and how would you know how much resource do you need to run your service so you could be optimized from cost perspective? My name is Hendrik, I'm from Blackon Technology Solution, and in this video we will talk more about how you could find the optimal resource to run your service and how you could scale them. Of course, there's no fixed formula to do this, but we have an approach by doing trial and error for this one. So before you get started, you got to have two things ready from your side. First one is your service is ready, meaning your code is ready to deploy. And the second one is you have like a maximum response time. So whatever the API is, this API should not process more than this specific response time. So that's what maximum response time is about. So let's get started about how we could find the optimal resource to run your service. The first thing you have to do is once the code is ready, and we try to deploy it with minimum server available. So if you are using VM, whatever the minimum like memory or CPU, you can use that. The most important thing is you have to know that is your service is running or not. If it's not up and running, means that your memory here is not enough. So you have to scale and add more memory. Let's say with 256 megabyte and 1 fee CPU, it's basically not be able to run your service. Then we know, oh, this is not enough, so I have to scale more. So let's say you scale that to the next level is you will do like 512 megabyte with still the same CPU, one virtual CPU. And we test again. And if this one is enough to run your service, means that's it for the memory part. Now, the memory part means that can the server run your service or not. And about the latency or the response time, it will base on the CPU and your code itself. So let's say it's up and running with 512 megabyte memory, but the response time still more than what we expect. Let's say we expect for at most 1 second, and the average response time is, let's say, 6 seconds. At this time, we have to consider to increase the CPU here. So to scale, we have to create another VM or something like Kubernetes pod with limitation still the same memory, but we add more CPU. So we do this until the app is up and running, and it could handle our latency or response time. So once it got less than 1 second, then this is what we call your minimum resource to run your service. And that's it. How do you actually find your minimum resource to run your service? Alright, let's now focus on this part. So this is not based on one single request. So the way to do this is we have to do what we call the performance testing. Let's say if we do like 100 requests per second, on average, what is the response time related with this? So with 100 requests per second from performance testing, if we got less than 1 second average for response time, then we could call it's okay. That's the minimum resource that we need. But if it's still more than 1 second to as average to get the response time, that means it's not enough. We have to redo this part. We have to scale the CPU or the memory if it's not up and running. So that's why we need the performance testing to get the average latency time, and either we can decide to scale or it's enough or not. The problem is when your user base starts growing, the cases will not be 100 requests per second. That will be 1,000 requests per second or maybe more. And it will affect the latency as well. So here is the base rule that we use for the maximum response time. So you have to be really careful to choose this number of requests per second. But yes, of course, if you get more than 100 requests per second, let's say 300, this will affect the latency. And in this specific case, it will come into what we call the scaling part. Let me explain about the scaling part in a few moments. Scaling divided into two parts. First one is what we call the vertical scaling. And vertical scaling is something we do when you run your service inside a virtual machine or VPS. The way it works is basically like this one. So once it exceeds your maximum response time, you have to scale up the memory and CPU. But this is not easy because the way of the scaling, you have to turn off your service, which is the virtual machine, make it up, scale it, and turn it on again. So it will take a downtime to do that. That's why we really not recommend to run your service under VPS or virtual machine because of this specific problem. And the second part of scaling is what we call the horizontal scaling. And let me explain you about this one. Horizontal scaling is something you only can do using orchestration like Kubernetes or OpenShift. And you really can't do it when you using virtual machine. So the way how it works is when you run your service inside orchestration, you have to determine what is the resource for that specific container. So let's say here we specify that a single container will consume 512 megabytes and 2 virtual CPU. The beauty of horizontal scaling is you can set kind of rule to scale up the container. Let's say when the user get busy, then when requests start growing, you want to do this. So for the last 5 minutes, if average CPU use is more than 80%, means it's get busier, and also average memory use is more than 70%, then you have to scale up. Scale up here means because it's using orchestration, it will create another container with this exact same resource to handle the request. So it will be more easier to do this kind of scaling to reduce the latency. And not only that, let's say once it get busy in specific time and then it slow down and it will be less busy for the request. We also can set kind of rule to scale down. Let's say in the last 5 minutes, if average CPU usage is less than 25% and average memory usage is less than 30%, then you have to scale down. Scale down here means it will remove one of the container so we can keep the cost optimized by using all the necessary container to run. And that's the beauty of horizontal scaling. In summary, with virtual scaling, it will be very hard to maintain because when you need more resource, you have to shut down the VM and upgrade it and turn it on again, and it will require some downtime, and it will be a lot of more expensive because you can't really like scale down and scale up your VM easily. So you have to stay at the some specific VM research to continue working on that. But with horizontal scaling, it will be easier to maintain because these specific rules, and it will create another container to handle more requests, so you don't have really required a downtime to do the scaling. And it will be more cheaper because it only uses some specific container when it's necessary. Okay, that's pretty much on this video, and see you on the next one.